In this video, we're going to talk about some different types of graphs that we might run across. The very first type that we're going to look at are scatter plots. So these are really useful types of graphs depicting our data. And along the x-axis on this one is waist circumference in centimeters. And here we have the arm circumference in centimeters. So we do need two variables for each data value that we have in order to do a scatter plot of the data. And really what we want to do is we want to look and see if there's any kind of a correlation going on between these two variables, the waist circumference and someone's arm circumference. And we can see that there is. They're somewhat random, but they also, as your waist circumference goes up, your arm circumference goes up, right? So this data all fairly closely lies on some line. And so we will look at this closer later on in the semester. There's something called the correlation coefficient. And we use the letter R to depict this. And the closer that this R is either +1 or -1, the more strongly correlated they are in a linear fashion. So this is a linear correlation coefficient. So it is only talking about a linear relationship. So also, this data, as we can see, this line would be going up as we move to the right. So that would mean that this linear correlation coefficient R would be fairly close to +1. If the data were going the other direction, going down as we move to the right, then the linear correlation coefficient R would be fairly close to -1. So, so again, we'll look at that a little bit later on in the semester. In this graph here, we have the weight and the pulse rates of males, and this is in beats per minute. And in this, there really isn't. I mean, this data is very random and all over the place. There's no distinct pattern that we can see in the data. And so this one would have a linear correlation coefficient that was closer to 0. So the closer the linear correlation coefficient is to 0, the less of a linear relationship there is amongst your data. So that's another scatter plot. Here's a third scatter plot, and so along the x-axis or the horizontal axis we have the weight of some pennies, and along the y-axis or the vertical axis we have the year in which the penny was made. And we can see a very distinct cutoff here that all of the pennies in the lower part were heavier. They had a weight of about 3.1 grams versus pennies that were made later on. They all had a weight that was around 2.5 grams. And so we can see that there was something that happened sometime after 1980. It looks like maybe 1983 or 4, something like that. There was some kind of a change that happened that changed the weight of the pennies. So they've always been the same size, so most likely it was a change in the composition, what the pennies were made of. So this next graph is called a time series graph. And so if you want to look at data across many years, this is a nice way to represent that. And so we can see some patterns. So the data in general was increasing most of the time. There was a little bit of a peak here. It went up really fast here. There was another spike here that went up, and then it decreased really rapidly right here. So we can just see some general trends of things that were going on. We also had a decrease going on right here. So most of these graph types are not things that I will have you reproduce. The things that you do need to know are the histogram that we looked at and the 3 different types of frequency distributions. So those are the ones that you really need to know how to do. We will use scatter plots, but we'll do that using technology. I won't ask you to do those by hand. This next one is a dot plot. It's very similar to a histogram. It has a little bit more information than the histogram does. We can actually see what our data values are. So for instance, there is one data value of 70. There's one data value of 50. This one looks like it might be about 56 or 57. It's hard to tell without tick marks there. We have one data value at 100, two at 101. So we can find distinct values of our data. But again, it's very similar to a histogram in that the height of the bar is sort of indicating how, has some indication of how many data values there are of that particular one. Another big difference is that, of course, in a histogram we have our classes, and so that covers several data values, versus with this it's our exact data values. So there's a stronger correlation between this dot plot and the stem plot that's up next. But they have a similar feel to a histogram. So the next one, a stem plot. So I use stem plots every time I give an exam. It's just a nice way for me to get a summary of the data and how students have performed on an exam. So in a stem plot, this over here is what we call the stem, and all of these are what we call the leaves of the data. And so you can pick out distinct data values in this graph, or in this depiction as well. So in the first line we have two data values, 50 and 56. In the second line, we have 70, 72, 73, 74, 75, and then a bunch of 76s, 77, and 78. So again, we can pick out exactly what our data values were from this stem plot. And it's useful, again, this is sort of like a histogram on its side, and so we can see the pattern. It goes up to a highest point and then comes back down. The next graph, a multiple bar graph. So this is nice when you're comparing two different populations. So here we're comparing male and female median income. And so we can see that there is a difference, right? The male median income is higher than overall than the female median income. Next, we have a Pareto chart, which is basically the same thing as a histogram, only this is for categorical data. And so, right, so this is leisure time, so this is what contributes most to our happiness. And so we can see how many people selected friends, how many people said that family/partners made them the happiest, how many selected music as the thing that makes them the happiest, right? And so the count, or the percent of people that said that, is along the side here. So about 64% of people said that family/partner is what makes them the happiest. Next, we have a pie chart. And so in a pie chart, you can calculate the angle. So how big is, oops, oh, I'm writing in red, that's why you can't see it. So you can find out how big this angle is here by multiplying this relative frequency to 360. So you can figure out what that angle is. Again, I won't ask you to create any of these charts except for maybe using some technology. So in Minitab, the statistical software that we will be using this semester. Next, we have a couple of frequency polygons. These, I think, are really nice when you're comparing two sets of data. So this is nice to see the difference between the high lead group and the low lead group. So these were IQ scores. So again, just another type of graph. Next, we have an ogive. So this depicts cumulative frequencies. And again, this is the IQ scores of the low lead group. So just another way to represent our data, and a perfectly good representation of that data. Now we're going to talk about some graphs that are sort of intentionally done to deceive people. And so these top two graphs are graphs depicting the same exact data. Notice though that on the first graph, it doesn't start until 30. And so basically, you've just got a blown up view of this, the top chunk of this graph on the right. And so it just really accentuates what is a pretty minor difference, um, which is why they're doing it. So this is the fuel consumption in miles per gallon. And so, Toyota really wants to, um, let everybody know that you can save gas if you buy their Toyota. That's sort of a way to deceive people, is just to take and look at the very top part of a graph. Like I said, it really accentuates what is a really small difference and makes it look really big. The next graph, so what makes this graph deceiving is how busy the interior of the bars are. So this is, right, it's a bar graph on its side. And again, they want to confuse you by having all that busyness in there, making things look a little bit different than they really should. So anytime you see a bunch of busyness in a graph, they're probably trying to deceive you in some way. Here is another deceiving representation. So this next one is the same data that was in this bar graph, this busy bar graph. And anytime that you're using volume to look at something that's really linear, it's deceptive. So this small cube looks deceptively smaller than the big cube. It is smaller and it should be smaller, but it's much smaller than, and appears much smaller than it should compared to the big one. So that's the deception, and using volumes to pick things that are really not, they don't have a volume relationship amongst them. So this is the same data. Again, this is a good representation of the data versus using these cubes. So again, this large cube is deceptively bigger than this small cube. And this is a much better way to depict this data. Okay, so that's it for looking at other graphs. Let me know if you have any questions, and have a great day.